Good afternoon, good evening, good morning from wherever you're viewing this presentation. My name is Kenneth M. Scott. I'm the President and CTO of Core Broadcast, an engineering, consulting, and commissioning company for television broadcast and high-end corporate video. We are based out of the beautiful Pacific Northwest just outside Seattle, Washington in the United States. Today we will present a live 46-minute demonstration on the tools and techniques we utilize to create extremely accurate design and drawing documentation for television broadcast, radio, telecom, high-end corporate, and audio-video markets. We will begin by time-stamping this presentation before we start, after drawing completion, and finally at presentation end. We begin by creating small fictitious devices to demonstrate the various dynamic capabilities of our equipment blocks, connector styles, signal converters, adapters, drawing layout, automatic wire numbering, and automated wire run list. It is important to note that we will be creating all devices from scratch so we do not overpromise or oversimplify our processes. The hows and whys are presented in multiple highly detailed step-by-step training videos that I'll describe in a few moments for current and future clients. I'll also explain a few of the most important tools for project managers, installers, and clients provided by default in using our tools, namely identifying all changes between drawing versions, cable and conduit calculations, device and drawing verification, power and heat loading, sortable and filterable wire run list, as-built documentation, and creating a professional and consistent output format. As you saw, I started a brand new copy of AutoCAD on my 64-bit Windows 10 machine. The first task was to create a new project to contain all of the files required in this project into one virtual directory. Then I saved the newly created file into the hard drive and added it to the active project. We start off by inserting a dynamic equipment block. You go to the Insert tool, select Block, and then paste it into the drawing. Next, we're going to size this block appropriately for the amount of connectors we're going to insert into this device. We're going to choose 3G SDI, ASI, or MUX, analog audio, and control network. We'll use the same complement of inputs for the outputs. The equipment block has general information about the device, like make, manufacturer, general description, power requirements, and sizing. It also provides a field for location on where this device is going to be located within a facility. The first and last device in the chain will include additional connectors to demonstrate internal and external flag references as well as remote CFE devices. The number one question first-time clients ask us about our drawing system is, what is it and why do I care? We have created a suite of tools that allow clients, designers, installers, project managers, and system integrators the ability to create extremely accurate designs and documentation more quickly with pinpoint accuracy. We can make this statement because we combine the automated and auditing capabilities of electrical AutoCAD with a purpose-built Windows 10 64-bit multi-threaded application designed to find and correct errors specific to television broadcast, radio, telecom, high-end corporate, and audio-video markets. We utilize the power of electrical AutoCAD to perform drawing and electrical audits, identifying 15 common mistakes that designers overlook in creating technical systems. It verifies common tasks like wire number and device name duplication, one-to-many, many-to-one, and intersection of wires, mismatches between label pointers and wire number references, internal design compliance and methodology, file and data structure verification, and authentication. Our electrical wire run list tool then collects and processes this raw data and performs a multi-level hierarchical search for audio, video, data, and networking components. It then analyzes the project level, block level, connector level, and wire levels associated with those devices using an advanced multi-layer algorithm. It identifies incompatibility of signal types like digital outputs into an analog input, high definition or ultra high definition into a standard definition device, and configurable multi-definition into various fixed standard devices. This tool also identifies the requirement to use unbalanced to balanced transformers, signal converters, and adapters required between broadcast and consumer-related devices. By default, our application performs secondary verification of device, connector, and wire references, as well as duplication of devices independent of system names. Auxiliary information is also analyzed to identify missing system components, flags, and wire data required to calculate power, heat, conduit sizing, cable length, connector type, and part numbers. This tool was purpose-built to globally update flag and equipment information, calculate power and heat loading for each room, rack, and device location, then modify specific visual reference points for viewing and archival purposes. The ultimate and primary objective of this application was to eliminate the tedious and time-consuming process required to create a 100% accurate wire run list from a drawing set. In the past, human-related errors, time constraints, and variations between drawing versions made it extremely difficult to create, bundle, and deploy cabling within a facility without countless labor hours interpreting design differences between drawing set to drawing set and wire run list to wire run list. Our secondary goal was to increase accuracy all while decreasing labor hours, tracking down common, we will call insertion errors, into the design set, thus allowing designers and engineers more time to focus on workflow and operational requirements of their clients. The comprehensive and advanced processing capabilities designed into this tool set eliminates the requirement to manually search through every drawing to identify equipment blocks that require part number updates. A global list of devices contained within the project is provided in a simple and user-friendly interface for modification. Our expertise in broadcast television and high-end corporate demanded a process or product that could detect and identify whether wire numbers are assigned correctly between devices, necessity to convert between signal types or connector styles, and determining electrical characteristics of the global system, cross-referencing all components to that specification. The outputting and formatting capabilities designed into this toolset is unmatched in the industry. It provides a sortable, filterable, and operating system agnostic web interface, as well as a local database that can be sorted, filtered, and formatted to user requirements to create wire run list, test sheets, equipment tracking, conduit sizing, power and heat loading, materials list, cable distances, automatic cable sizing, and printable wire labels. You will find huge gains in efficiency and accuracy not equaled by any other product or service currently on the market. In taking a look at this dynamic equipment block, you will see you have the ability to define whether this is a customer furnished device, or CFE. You also have 38 predefined styles to dictate shape and coloring that can be applied to each block. All the components will adjust its shape and size based on your selection. Our approach and system is based on three main components: Electrical AutoCAD version 2013 and above, the core template file which provides critical embedded attributes and properties, and the ElectricalWireRunList extraction and verification tool. AutoCAD Electrical is required to use the extraction tool, but it is not required to create equipment blocks and system designs. In this presentation and subsequent videos, we'll walk you through many of the benefits and capabilities of our product lineup. If you have any specific requirements or suggestions for future product updates, contact us immediately and we'll research modifying our viewing tool or template file for your organization. At this moment, I'll ask all those individuals who are looking for detailed training on how to use our system, please proceed to video 1, where the basic steps in configuration and setup of AutoCAD is presented in a step-by-step process using our design package toolset. Video 2 will walk you through creating dynamic equipment blocks and simple systems, as well as how to properly bind or electrically enable the equipment blocks. Video 3 will showcase the benefits of electrical AutoCAD's auditing, automatic wire numbering, insertion of predetermined connector style and functionality, multi-page templates, and system-wide information linking. Video 4 will showcase our electrical wire run list extraction and verification tool utilized to identify errors in your design and update critical information into a feature-rich web interface and local database. The main focus will demonstrate dynamic generation of drawing set versioning, equipment tracking, and wire run list templates on a room-by-room, rack-by-rack, device-by-device, and wire-by-wire basis. Finally, in Video 5, our bonus video, we will demonstrate how our tool can directly modify and upload equipment block and rack elevations, cross-referencing flag data between drawing and pages, auto-calculating wire distance information, heat and power loading, conduit sizing, cable distances, and connector requirements. As designers, we know the most difficult deliverable to internal and external clients is providing accurate and detailed designs in spite of changes that occur prior to deployment, during deployment, and after deployment. These changes can occur from operational requirements, in-field modifications, and deployment schedules. The ability to identify those changes is essential to increase on-site productivity, reducing risk, and ultimately a greater return on deployed human resources. We hope this demonstration showcases the versatility in modifying the style and color of equipment blocks, signal type and functionality of connectors, automatic wire numbering on a local or global scale, and the use of special connectors to create signal converters and adapters for wire number pass-through. Due to the fact that every system typically has a bulkhead or patch bay in the design, a multifunction patch bay with a fully normalized, fully terminated input and output for video and ASI signals will be used. Half normal, half terminated I/O for the analog audio, and a non-normalized, non-terminated data patch for networking will be included. We will also demonstrate the ability of these dynamic blocks to adjust its shape to simulate internal expansion. I'll take a short musical intermission to finish up these devices. Many times, it is necessary to use placeholders for remote or known locations for electrical signals, but the specifics about these devices is unknown during the design. An example of this would be a demarc location for a Telecom OC3 circuit. We know this device is required for the system, and we may even know its location. This remote style device contains two angle brackets on each side. It contains all of the attributes and fields of a dynamic equipment block. We will also show the automated capabilities of internal and external flags to update its partner flag's information and wire number using similar identification numbers. To be more accurate in this demonstration, we will also create one more drawing file with two copied equipment blocks and one flag linking back from the original drawing. This process will add additional time to our design, so we will provide one more musical intermission. Now that our equipment blocks have in place, it's time to wire the devices. Before physically attaching the devices, it's important to select the wire layer associated to the signal or connector used to allow global updating of attributes and colors based on your in-house standards. Using Electrical AutoCAD's Insert Wire tool, a green X will appear over a properly formatted connector style. By selecting each connector, you can span a wire between input and output devices. This tool auto-calculates the proper path between the connectors and user-selected nodes, saving even more time in design layout. You've probably wondered by now, why have we decided to use all of these various colors and connector styles? For two specific reasons. One focused on the user, the other on system design. For the user, it's easier to identify the signal types via colors. The other allows the ElectricalWireRunList tool to identify the various signal types within the drawing. It will then warn you about accidental connections or mismatches between signal types. One of the biggest benefits in using Electrical AutoCAD to lay out your system is its ability to understand what wires are. By default, Electrical AutoCAD will not allow you to intersect wires. It will instead jump over any perpendicular wire in its path. Unlike in other AutoCAD versions where you have to do this step manually, this is an automated feature. It also provides you a tool to swap the direction of the hop from horizontal to vertical or vertical to horizontal. In electrical, this is called a wire gap. When designing complex wire networks, this is a huge time-saving feature. Due to time constraints, we will not show you this automated feature in this demonstration. However, we will go over this extensively in our training videos. As you can see, we're finishing up the last remaining items for Drawing 1. By default, AutoCAD automatically saves a file in case of disaster. However, out of common practice, after any major change, I manually save those files. Next, we'll continue on to Drawing 2 and finish off the wiring in that drawing. In being an Electrical AutoCAD user since version 2007, I can give you one tip to prevent major headaches in using the wiring tool. Select your wire layer, then immediately select the Insert Wire button. If you only select the wire layer before placing the wire in your drawing, it will default back to the previous wire selected, driving you crazy in the process. So step 1, choose your wire layer. Step 2, press your Insert Wire button again, then lay down your wire. Rinse and repeat. We only have a couple more wires to go, then we'll save this file and insert our wire numbers. The Insert Wire Number tool has many different options available to you. By default, it will insert the wires from a top to bottom, left to right style layout. It will also auto-increment from number 1 up to infinity, as long as the sequential mode is selected. The interesting thing about this tool is it has two modes of operation. One, it can automatically assign a fixed variable for every wire number, which would prevent auto-updating of that number in the future. Or it can self-assign and re-update that number depending on drawing layout. If the system variable was set to fixed, the only option you have available to you is editing each wire independently. It's now time to auto-populate the wires across the entire drawing set using the Insert Wire Numbers tool. If you are a detail-oriented individual, you can use the Edit Wire Number tool to manually define wire numbers on a wire-by-wire basis. As you can see, the wire numbers are populating between every device and on every connector. One thing to notice is the flag A output is going to the flag A input with NTC-006. The next flag, 1002, is on page 2, so we should expect to see SD-001 to auto-populate to drawing number 2. We'll first save the file to guarantee that all changes have been saved to the drawing, and then press the Update Signal References. We will then apply this update to the entire project. Taking a look at the drawing one more time, you will see the impedance transformer with DA-001 is passing to the other side of the connector as DA-001. This is exactly the intent we are looking for with this Direct Connect product type. We'll update the reference for drawing 2 one more time to fully populate both sides of the connector reference, and use the Insert Wire Number tool to populate the wire numbers on drawing 2. The final step is to verify that all changes have been saved to drawing number 2. My final default step is always to go back and resave each drawing to verify that all changes have been made before going on to the next step. Next, we will perform drawing and electrical audits within AutoCAD to find and resolve physical interconnection errors. Once the drawing audit report is complete, it will show any errors or corrections it made to the drawing set. This is an automated process with no user interaction. The electrical audit will look for 15 product-specific errors and will report them in a tabular format if any errors are found. In our drawing, you will see duplicated blocks, but should be ignored until further examination. AutoCAD does not have the concept of a spanning or continuing equipment block. For this reason, you will always have equipment block errors in your drawing set. This is the power of where the ElectricalWireRunList extraction and verification tool comes into play. It does understand the concept of a continuing and expanding block, and it not only looks for the system name duplication, but also look for every other identifying marker. After all remaining errors have been corrected, it's now time to use the ElectricalWireRunList tool to identify industry-specific errors. I selected the proper AutoCAD version, then selected the currently active project name. Once loaded, the verification tools will now be available. By pressing each verification button, all errors that would affect the final output integrity will be listed in a yellow highlighted background. Anything that will not affect the integrity of the final output will only show a green background. If all verification steps are identified as green, the Extraction and Quick View button is now available. Pressing this button will give you a built-in view of the wire run list. Now at this moment, I'd like to demonstrate the output capability of this system, but before doing that, I want to prove that there is no information that has been pre-published to our web interface. I will attempt access to the web interface location based on the active project name. As you can see, the page is not found. Okay, let's create the web interface by sending the PHP and SQL to the primary server. Let's take another look at the web interface by refreshing your browser. Now you can explore the 100% accurate wire run list through the web interface. Obtaining a password to access this information directly from your computer requires contacting our customer service department requesting the live demo password. As you become more adept at using our system, you will notice the Version Changes button is currently missing. Since this is the first extracted drawing set, there is no additional versions to compare against. Let's go back and make a few random changes to the drawing set and update the revision history. One of the biggest benefits you receive by using our ElectricalWireRunList extraction and verification tool is it has the ability to calculate up to 40 room-to-room distances, including inner room dimensions for the total wire length required for the system, as well as determine the cable type utilized for that distance. If this information can be determined by on-site personnel, project manager, or even a site survey, the materials list and project prepping can dramatically be reduced, which increases the efficiency of project deployment. Throughout this entire demonstration, I have never left the drawing set. All content created using our tools and techniques are derived from the drawing set. This includes all calculations, all revision numbers, all distances. Everything focuses on one centralized idea that the designer has the total control and responsibility for providing accurate and timely information for the project. All of the information required to produce the most accurate drawing set requires the external stakeholders to provide accurate and timely information to the designer to be able to produce that information. To ease drawing workflow challenges, we also provide a legend on each one of our drawings describing the functionality and capability of our connectors, signal types, and color codes. Each of the 12 oversized D, oversized C, and B sets have their own color sequence, which gets referenced back to the drawing set for easier design and manipulation. We will refresh the data, then re-verify all the layers. The new revision number has been identified, so we can post that information to the server and refresh the web browser. The version changes option is now available, showing the changes between drawing sets highlighted in blue lettering. There are many options to display your information. The most common ones are poll, test, and MFG checkboxes. Poll refers to poll list format. Test includes completion checkboxes. And MFG adds manufacturer information to each wire number. The equipment button allows you to track equipment, serial numbers, and IP addresses. The purchase option provides equipment tracking templates for local and on-site project managers. Our designer's toolset demonstration is almost complete. However, in keeping my promise for a 46-minute demonstration, I will say that if this design workflow interests you because of accuracy, time-saving techniques, advanced verification, ability to customize the data on a room-by-room, location by location, rack by rack, or device by device, please contact technical support via phone, email, or web, and we will assist you with your next broadcast, radio, telecom, high-end corporate, or audio-video project. We will leave you now showcasing a little more information that can be obtained from the web interface and the ElectricalWireRunList extraction and verification tool. Thank you, and have a pleasant day, evening, or morning.